This is the last topic of section 1.3, the more complicated types. We're working with fractional functions involving radicals. So we have to, remember both rules, that the denominator, the bottom of the fraction, can't be equal to 0. This shouldn't be equal to 0. I'll go ahead and start writing, why not? We know that negative 5 plus 2x, square root of all that, the bottom of the fraction, denominator cannot be equal to 0. That's one condition, right? What was the other rule about the square root? That radicand has to be greater than or equal to 0. So what's the radicand? What is underneath the square root? Just this part. I'll go ahead and say negative 5 plus 2x has to be greater than or equal to 0. So we have to consider both cases, and we have to find the intersection, the interval that satisfies both of these conditions. So I'll start with the one on the orange first, okay? Take a look at the one on the orange. To get rid of square root, what do we do to both sides? To get rid of square root, I'm going to square both sides. Square both sides. If you do that, you get negative 5 plus 2x is out of the square root. But look, if you square 0, 0 squared is still 0. Okay, now look. I'm going to go ahead and just kind of look ahead. Do you see that this orange piece is telling us 5 plus 2x should not be equal to 0, right? So I was about to set it greater than or equal to 0, but what they are saying is, hey, the inside part cannot be equal to 0 because if the inside part is 0, the entire square root turns into 0. And we are not allowed to have 0 in the bottom of the fraction. So I'm going to go ahead and adjust this a little bit. Instead of saying that negative 5 plus 2x is greater than or equal to 0, I'm going to have to take away that 0. I'll say that it has to be strictly greater than 0, because if it is 0, the bottom of the fraction becomes 0. So that's why we have to take away this equal to bar, because it can't be 0 in this case. All right, so I'll go ahead and solve this green one. I can add 5 to both sides, plus 5, plus 5. If I do that, I get 2x is greater than 5. Now let me divide both sides by 2. Divide by 2, divide by 2. We got the answer. X has to be greater than 5 over 2. So if I may have to make this a little bit smaller, you guys. I write a little too big. Go ahead and make this a little bit smaller so that I can graph this over here. I'm going to plot 5 over 2 in the middle, and I will draw an open circle. Okay, because it can't be 5 over 2. If it is 5 over 2, the square root will become square root of 0, and square root of 0 is 0. That will result in getting a 0 in the denominator, and that's what we're trying to avoid. So it does say that it has to be greater than, right? So if it's greater than, you go to the right side. So here's the domain of this function. Domain is from 5 over 2 all the way to positive infinity. So I know they're a little bit tricky. So hopefully you practice goal number 5 and goal number 6, domain of a rational function, domain of square root function before you are watching this, because this topic, we're putting both of those together and we have to kind of think about the interval that will satisfy both of these conditions. Okay, so let me go down to number 2. And you know what? Number 2 is something, example 2 is something that I always put on the first test. Domain of the function, and this is a fraction that has a square root. So let's go ahead and set up these conditions. First of all, I know that the denominator cannot be equal to 0. Denominator is 8 minus 3x. That shouldn't be 0. What's the second condition? The second condition is that radicand has to be greater than or equal to 0. And what is a radicand? What is under the square root? It is 6 plus x is greater than or equal to 0. So we wrote both of those first. I'm going to go ahead and solve each of them. So first of all, if I'm solving this, I'll subtract 8 from both sides. If I do that, I'll get negative 3x can't be equal to negative 8. Divide both sides by negative 3. I get that x can't be equal to positive 8 over 3. I'll circle this. So what we're going to do is we're going to plot an open circle at 8 over 3. 8 over 3 is what? 2 point something, right? All right, so I'm just thinking about decimal so that I can graph it in the right place. All right, let me go ahead and do the second one. I have an inequality that I will start by subtracting 6 first. If I subtract 6 from both sides, I get x is greater than or equal to negative 6. Hey, I think we're done. We're done solving this. All right. And for this one, I will plot a closed circle at negative 6. And you know why? Because we have this bar underneath it. All right, let's put these two together in a graph. Okay, let's put these two together in a single graph. All right, which number is smaller? 8 over 3 or negative 6? Because a smaller number should be on the left side. Any negative number is smaller than any positive number. So you put the negative 6 on the left. Draw a closed circle because negative 6 has greater than or equal to symbol, right? I know that I'm going to be going to the right from negative 6 because it is greater than negative 6. All right, go ahead and just plot somewhere 8 over 3, but this is going to be an open circle. Okay, now take a look. I'm going to do something fun here, okay? Because of this inequality, x is greater than or equal to negative 6, I should start from negative 6, but go which direction? I need to go to the right. So I'm going to keep on going to the right, keep on going to the right, but I noticed there's a hole in the ground. I need to jump over this. I should not jump into this because if I have a value at 8 over 3, well, what's going to happen? The denominator will be 0, right? So don't step into that hole, just keep on going. And that is a domain of this function. Oh, wow. So let's go ahead and write this in interval notation. I can clearly see two intervals. The one that connects negative 6 to 8 over 3. So that interval is going to be bracket negative 6, comma, 8 over 3, close the parenthesis. Be very careful with the circle types. For a closed circle, we're using a square bracket. For an open circle, we're drawing a parenthesis, okay? Do the union symbol, and let's take a look at the second interval that starts from 8 over 3 and is going all the way to, you know what, positive infinity. So for the green interval, that's going to be 8 over 3, comma, positive infinity. So that's how you find the domain of this fractional function. So yep, definitely more challenging than the other ones that we looked at in this lesson. But because these topics, they're putting everything kind of together, asking you to think about the intersection of these restrictions. Okay, let's do the last one. And you know, I'm being a little careful about this one because there is a section later on in 161 where we're going to look at solving a rational inequality. So I thought this was not really appropriate for this lesson because we didn't really talk about that, but I'll try to see if I can explain it without going too much into solving rational inequalities. So let's see. So I have a fraction under square root. So I'll go ahead and just write down my rules first. I know that the denominator cannot be equal to 0. Denominator cannot be equal to 0. So what's in the bottom of the fraction? X minus 6. So we know that x minus 6 can't be equal to 0. Add 6 to both sides. Plus 6 plus 6. What do we have? X can't be equal to 6. So we're going to draw an open circle at 6. Okay, we're going to draw an open circle at 6. Now what else? We also know that the second rule is that radicand, whatever is underneath the square root, has to be greater than or equal to 0, right? And what's under the square root this time? The entire fraction. So go ahead and say that this fraction has to be a positive or has to be greater than or equal to 0. Now this type of problem is something that I have to teach in section 2.6. So let me think. How can I explain this without going too much into details? For the fraction to be greater than or equal to 0, think about this for me. You have a positive number on top. Okay, you have a positive number on top. Okay, for the fraction to remain positive, can you have a negative in the bottom? No, right? Because positive divided by positive is bigger than 0. You can't have a negative in the bottom. So what we know is that x minus 6 must be a positive number. X minus 6 must be a positive number. Why? Because positive divided by positive is bigger than 0. I hope that makes sense. Okay, I hope that's making sense. So this must be the bottom must be also positive so that we have positive 12 divided by some other positive number being greater than 0. Right? Because if the bottom of the fraction is negative, positive divided by negative will result in a negative number. So that's why we know that x minus 6 has to be greater than 0. But you know, because that's the bottom of the fraction, it can't be equal to 0. So it is wrong to say that it is greater than or equal to 0. You must say that the bottom of the fraction must be bigger than 0. If I solve this, that's simple. X has to be greater than 6. And both the red circled answer and the blue circled answer are excluding 6 from the domain. If I go ahead and graph this, I have a 6 right here with an open circle. Open circle at 6. Which direction are we going? X has to be greater than 6, so I must go to the right. Okay, so here's the domain of this function. Domain is positive 6 all the way to positive infinity. Now, definitely these three were challenging. They were fun. I want you to practice this, okay? They were three different looking problems, but they are all under same goal topic in your Alex homework. So if you're having trouble with this particular topic, we can go ahead and talk more about this, and I can add an extension, and we can, go back and work on this again, okay? But I think it will be difficult to just learn this topic by just watching a video with 3 examples. So I expect you to come back next week so that we can talk more about this topic again, okay? All right, so the rest of the topics I won't be able to go over. Well, I will not go over. I think you can, handle these 3 topics. First one is the vertical line test, okay? We also called it pencil test, to see whether a relation is a function given a graph, identifying functions from relations, and determining whether an equation defines a function. So for these 3 topics that I did not go over, I want you to look at the resources in your ebook or the videos or the examples provided by Alex to try these 3 review topics, okay? I'm going to go ahead and process this very last video, put the notes on Canvas for you, and wish you good luck on the asynchronous part of this week's lesson.